So October 2020 paper 4 variant 1 continuation. Question 4. A large test tube containing a liquid at room temperature. An electric heater is immersed in the liquid and is switched on. The thermal energy supplied to the liquid by the heater, the temperature of liquid increases until it reaches its boiling point. The liquid then starts to change into gas. Describe in terms of molecules and their motion how liquid differ from gases. So you have to state the difference between the particles in terms the motion of the particle in liquid and in gases. Basically, in liquid, the molecules are relatively closer as compared to that of gas, and in gas, the particles. If you write a term, molecule become smaller. That is not the valid term. Like the reason is that because the size of the molecule does not change, the spacing between the molecule only changes. So you should always mention like a space between the molecule is smaller in gases as compared to that of gas. And in liquids, the molecules are sliding pass over each other, but in gases, the molecules are free to move. And the particles are moving randomly at high speeds. Yes, you can use the term particle as well. But if you see the question, it's right to say particle. That does not make difference to the answer. But if you see, they say in terms of molecule. So in terms of molecules, so better use a term. They already mentioned that they want you to use the term molecule. That's why. But if you use particle as you are used to write, that is also correct. The next part, describe what happened. Molecule is a specific term which is used for group, but particle is a general term which can be used for atom, for ions, for what we say, a group of atoms. So particle is a general term which can be used at any place. Like I can atom, I can say particle. Molecule, I can say particle. Uh, Cluster of or group of atoms, I can also say particle. But molecule is specifically used for group of atoms. Describe what happened to molecule of a liquid as the temperature began to increase. So what happened when the temperature is increasing? Temperature and kinetic energy are directly proportional. So molecule will move, gain energy, move faster, or the kinetic energy will increase. And whenever the substance is heated, it always expand. So molecule gain energy, move faster and away from each other. Why in this case you cannot mention Mohsin, why you cannot mention like about the intermolecular forces? It is right, but the thing is about the intermolecular force, it is valid, this explanation, when the question was explain what happened when the liquid is boiling. Then you should your answer should include that energy used to break the intermolecular force. It is not wrong to say intermolecular forces diminish or reduce and particles move away, but normally if there is a change in temperature, it should be in terms of vibration and kinetic energy and particle move away. Really, and when it is about the changing in state, then energy used to break the intermolecular forces. Explain in terms of molecule why a supply of thermal energy is needed to change the liquid into gas. So why we need energy to convert liquid into gas? So here we have to break the intermolecular forces. The next part, yeah, the molecules overcome the force of attraction. The density of the liquid in a test tube is 0.86, so it means it is not a water. Volume is 50 cm cube. The thermal energy, the liquid reaches a boiling temperature, absorb 18,000 joules. Calculate the specific latent heat of vaporization. Latent heat of vaporization is energy divided by mass. When I use this formula, I have the density and I have the volume. So density is mass over volume. So mass is density into volume. So first 0.8 multiplied by 50. That will give us answer in gram. 0.8 into 50. What's the answer for the mass? 43. So that will be 43 grams. And if I solve this question without converting the mass into kilogram, then important thing is the unit. Like the unit will be joule per gram. So 18,000 divided by 43, what is the answer? 18,000 divided by 43. 41 point in kilo, okay, that's 418.6 or 419 joule per gram. Or in kilogram, if you want to convert, this 420 is not joule per kilogram, it will be joule per gram because the mass here is in gram. So unit conversion, you always, whenever you're solving a question in physics, some questions appear to be direct, like it appears that all the things are given, you just have to substitute in the formula and get the answer. But for these type of questions specifically, which appear to be very simple, you should check the units that all should be in SI unit. A metal container is used to cook food. The metal container has a thick walls. Hot cooking oil at a temperature of 120 is poured into a container. The outside surface of a container gets hot. Some of thermal energy passes through the metal because of vibration of atoms and collide of neighbor molecule and transfer energy. Explain how the rest of thermal energy is conducted through the metal container to the outside surface of another by another process. Basically in conduction, yeah, that's right. In a conduction, what happened that the particles in a metal, the particles are tightly packed together, so the lattice vibration transfer the energy. But there's also another way, the electrons, free electrons, these electrons also collide with the molecules, move from hotter region to colder region. No, it's not the movement. This region is hot. Hot region to cold region. They collide with the other molecules and transfer their energy. So by electrons it happens. Move from hot region to cold region. Collide with molecules and transfer energy. The next part, the outside surface of the container is brightly polished and shiny. Explain how this reduces the power that energy. Explain how this reduces the power that needs to supply to keep oil at correct temperature. So outside surface is shiny and polished. How this is an advantage? Because shiny surfaces are poor emitter and they are good reflector, poor absorber and poor emitter, they are good reflector. Instead of conducting heat, you cannot mention a shiny surface does not conduct heat. It should be in terms of reflection, emission or absorption. When you discuss about the texture of the material, you should specify like it's a shiny, so it will not absorb or emit too much energy. So shiny surfaces are poor emitter, so it will reduce. It will not. Poor emitter means also poor absorber. So most of the heat will remain in the system. The metal container is spherical. Spherical containers has a small surface area, then long thin container of same volume. Explain advantage of using a spherical container. What is the advantage of using a spherical container? Look, if you have a large container, it will have a large area, so rate at which it can lose the energy will be higher. But if you have a spherical container, it will have a less area, so it will reduce the heat loss. Yeah, most of the heat will be conserved within the system. So you have to relate the heat loss with the surface area. In question 6, figure 6.1 shows a tank that is viewed from the above. The depth of the water is different in two parts. Look, why they use a dotted line and the continuous line, it is showing like two different regions of the wavefront. Like if this was representing crests, then this will represent troughs. Or it can be vice versa. As the wave passes from one side to other, the direction of the wave changes. Explain why the direction of wave changes in a way as shown. So basically, what happened, why the direction of the wave changes? First, what happened to the speed, increase or decrease, when it traveled from one region to another? By looking at this figure, so speed of the wave decreases. So when wave is traveling from one medium to another, its speed decrease. Then as the speed decreases, what is the effect of decrease in speed? The two mediums, the wave is having a different speed. Difference in density, the two mediums, difference in density cause speed of wave to change direction, because here the wave is traveling faster and this part of this wavefront which is in the other region, which is also a shallow region, yeah, there is no change in frequency. The wavelength, what happened when it travel, we have this formula v is equals to f lambda. So v divided by lambda is equals to f. If the speed decreases, the wavelength also decreases, but the frequency will remain constant. Frequency does not change. The speed and the wavelength changes as it travels from one medium to another. So what happened? The speed of the wave is changing or it is decreasing, and the wave speed is smaller in the lower region as compared to a top region. How both decreases and the frequency remains same? Example, if I say the speed in this region was 10 and the wavelength is 5. So what is 10 divided by 5? That is the frequency. So 10 divided by 5, that is equals to 2. Here what happened? The speed decreases, the speed is 6 now and the wavelength example 3. So 6 divided frequency speed divided by wavelength. So 6 divided by 3, that is equals to 2. So the frequency remains same. The speed and the wavelength both decreases. Because frequency is a ratio between the two. When the wave travels from one medium to another, both changes speed and wavelength, but the frequency remain constant. So how to write the answer? You will mention in a top region the wave is traveling faster. In a bottom region the wave is traveling slower. The change in the speed is caused, the change in direction is caused by change in speed due to the difference in the density of the two mediums. In the drawing also we decrease the wavelength. You can see that this is the wavelength in a deep region and wavelength in a shallow region. So in a drawing also you can clearly see the wavelength appear to be decreased. The speed of the wave in the left hand part of a tank is 0.39. Use the information, determine the frequency. So speed is 0.39. What is the wavelength? Wavelength is the distance between two successive crests. So crest, trough and crest. The distance between crest and trough is 2.6. So remaining this also 2.6. So what will be the wavelength? 2.6 plus 2.6, that is equals to 5.2 centimeter. But speed is given in meter per second. So V is 0.39. The wavelength is 5.2 centimeter, but I should have the same unit, so it should be meter divided by 100, so 0.052 meter. Then we'll get the frequency, which is the ratio between speed and the wavelength. What is the answer for the frequency? That will be 7.5 hertz. Determine the speed of the wave in the right hand side tank. So we know the frequency does not change. So as the frequency is not changing, the frequency on the left hand side will be equal to the frequency on the right hand side. But to use this formula, if I try to use this formula, that the frequency does not change, so V1 over lambda 1 is equals to V2 over lambda 2. I don't have, because we know the speed in medium 2, that is given using left hand side. Speed in medium 1 is given, the wavelength is given, but we don't know the wavelength in the second medium and we don't know the speed in the second medium. The speed will decrease, that's obvious, but we don't know any of them. So if we don't know the speed, what we can do, they have a inverse. So what we can do, the angles are given, so we can use the concept of the refractive index to calculate the new speed. So how we'll use the refractive index? Refractive index means ability of a medium to bend light. The angles are given, but what about angle of incidence and angle of reflection? See, the direction of the wave, the arrow is representing the direction of the wave is always perpendicular to direction in which the wave travels. So this is the direction. Now what is this angle? We always take an angle from the normal. So what we have to do, we have to draw the surface is given. If I draw the angle, like this is the direction in which the wave is traveling. The angle with incident, angle of the wave front with incident is also given, and angle of the wave front with refracted is also given, that is 33. Or I can also use the same concept, like if I draw a normal here, normal is always perpendicular to the surface. So refractive index is equals to sine angle I over sine angle R. So if I calculate the refractive index here, the angle of incidence for a wave front is 45, so sine 45 divided by sine 33. So sine 45 divided by sine 33. What is the refractive index of the second medium? Sine 45 divided by sine 33. That is equals to 1.29. Look, you can take two angles. You can solve by this method, this one by two ways. That will not make difference to the final answer. How it will not make difference? It will also be 0.8 times the original one. So using this concept, we are solving the question. Is it clear?
Sir?
Yes.
Sir, whenever we're calculating the refractive index, usually for light, we are measuring the angles, the direction of the light ray.
Yeah.
But here it's just given the wavefront.
Right.
So how will I?
So the direction of the wave is perpendicular to direction of the wavefront. If this wavefront is given, this will be the direction of the wave. The refracted wavefront is given, so this will be the direction of the wave. And then you have to
Sir, how
draw
will I
the,
calculate the angle? Yeah.
you will draw a normal. Normal is always perpendicular to surface. So you will draw a normal here. This is a normal which is perpendicular to surface. So when we work out the angle, this angle, it will be 45. As the wave fronts are there, the surface, the total angle, this is 45. So remaining angle is 45. The total angle is 90. So what is this angle? This angle is also 45. What about the other angle? This is 33. The surface and the wavefront angle is 33. And this angle, the total angle is what will be this total angle? This angle will be 57. So remaining, how much is this angle? Yes, Safif?
So is it 33?
Yeah, here
So
it's
it's
which one?
so the refractive angle of refraction.
Yeah, they basically how we can calculate this. Look, we have a refractive index. Either we can use sine angle I over sine angle R, okay, or we can use the angle of the wavefronts also. Both ways this question can be done, and then after knowing the refractive index, we know refractive index is speed in medium 1 divided by speed in medium 2. Normally, because we did these type of questions for light rays, that's why speed of light in air divided by speed of the light in a medium. So if I'm using this formula, like I use the total, what I'm calculating a refractive index of the medium. These formulas are derived from a main formula, which is n1 sine theta 1 equal to n2 sine theta 2. This is a main formula which is also called a Snell's law. So first, what I will do, I will draw a normal here. I drew the direction for the incident one, and I got the angle of incidence to be 45. Okay. Then I will draw the refracted ray. So refracted ray should be 90 degree to the wavefront. So when I draw a refracted ray, if this total angle is 57, so this angle should be 33. Is it clear?
Yes, sir.
So when I use a formula now, because when I was solving question with reference to which one is 57, Hashim? Which angle you are asking? Which one? You can use a mic.
Yes, sir. This one, the one with 33 and 57. No, not this one. Yeah, this one.
This one. This is
33.
already. What is the norm? When I drew the normal is 90 degree. So out of that, one part of the angle is 33. What will be the remaining?
12.
12.
Yeah.
Normal is always 90 degree.
Yeah. Okay. Yes. 90 degrees. Sorry.
So normal is always 90 degree.
57. Yes.
So when I measure these angles, the angle of incidence is 45. This angle is 57. So angle with a normal remaining. So if this will be 33. So if angle of refraction I'm solving, because this question can be solved with both angles, it will give the same result. Angle of incidence is how much? Angle of incidence is 45. Angle of refraction is 33. What is the refractive index now? Sine angle I over sine angle R. Sine 45 divided by sine 33. What is this answer?
It's 1.3, 1.29.
1.29. So means this medium is having a ability to bend 1.29 times more than the other medium. So we have the formula n is equals to c by v. Like speed in medium 1 divided by speed in medium 2. Because this is a formula, if you remember the refractive index for light, we write speed of light in air divided by speed of light in a medium. So speed of light in air, actually that is speed in medium 1, and speed of light in the other medium when it travel, that is speed 2. So basically refractive index is also a ratio between the speeds. So if we know the refractive index 1.29, what was the original speed? That was 0.39, I guess. And we are finding the speed in medium 2. So when I cross multiply, speed in medium 2 will be equal to 0.39 divided by 1.29. What is the answer?
0.3.
0.3. So 0.3 meter per second. And same way, when I solve the same question using a wavefront angle, I was getting the same answer. Because what I was using in a wavefront method, I was using a change in the direction of the wavefront. That's why I use the angle 57 there instead of 33. But I can use this method as well and get the answer. Is it clear?
Yes, sir. Thank you very much. Sorry for all the trouble.
No, it's okay. Like the question, the reason why this question is a bit confusing is because instead of giving the light waves, they give you water waves. Normally, these type of questions are with the light waves. So one of the speed is fixed and you're getting the second one. I'll share another link and continue the discussion. Question 7 onward.